In the previous lesson, we had a look at what we call reciprocal relationships, and this time we're going to give it a name. These graphs are actually called hyperbolas. And down below here, you can see exactly what a hyperbola looks like. It's quite an unusual graph that is split in two places, and I'll show you why it's split shortly. Now, we call it a hyperbola, and it says there are three ways of writing the same equation for hyperbola. We can either have y equal to some constant like number 2 or 3 over x, or we could have x at the top and some constant over y, or we could multiply x and y together to get k. But this is the most common one. Y is equal to k over x, and it looks like this. Now, we're going to draw one of these graphs, and I'll illustrate why there is a break in here. You'll see this on the next slide. All right, first thing we've got to do is to get our calculators out and work out the answers to these questions. I want you to have a go at this now. I'd like you to pause the video. I want you to work through and put 6 over minus 12 and get your answer down here. I'll give you the first one so that you can see that you're getting it right, but this one would be minus a half. And I want you to go through and complete all these other ones. So pause the video for a minute and you write in what you think are your answers, and then we'll check and see. All right, let's write in our solutions. I'm going to finish these off, and you double check that you actually got these right. And if you didn't, you need to find out what you're actually doing wrong with your calculator. So we'll finish these off. That's minus 12, minus 18, minus 24. There's 24. 18, 12, 6, 3, 2, 1 and a half. Now, if you didn't get any of those correct, you must check and see why. But I just want to show you why there's a what we call a discontinuity. A discontinuity is a break in the graph. There's no x equal to 0 here. What I'd like you to do is to put this into your calculator and tell me what you get, or speak out to your teacher. And when you do that, you'll find that you get usually a calculator will give some sort of error message. And that's because you can't divide 0 into any number at all. So 0, you can't say 0 goes into 6 so many times, because it's an impossibility. So that's why it breaks. When you've got an x value equal to 0, there's no answer. So therefore you can't plot it. So let's plot these points. Now, I'm going to just do this very, very roughly, but if I was to say put 10 here and 20 here on the y-axis, and do the same along here, 10 and 20 and minus 10 and minus 20, and down here minus 10, and I better push this up a little bit so we've got a bit more room, and minus 20. If you were to plot this, you would find that the graph would have the typical hyperbola feature that you saw on the previous slide. Let's have a look. When you've got x equal to minus 12, it's somewhere here, you've got a very small number, something like this. When it's minus 6, it gets a little bit bigger. When it's minus 3, it gets a little bit bigger again. And notice as it gets very, very close to 0, it gets, oh look, we're doing that on the wrong side. Let's get rid of those. Yeah, okay, we'll go down this way. We'll go down, when it's minus 12, we've got a minus half. So we're talking about a number. There's 10 somewhere around about here. All right. And then when it's minus 6, it's minus 1. So somewhere around about there. When it's minus 3, it's minus 2. It's starting to get a little bit bigger. And what you find is as the number gets closer and closer to 0, the number gets bigger and bigger and bigger like this. So in fact, when you draw this graph, very hard to draw, but it curves around like this and goes this way if I did it like that. Never touches the line, by the way. And on this side, if you look at it, when we've got 12, we've got a half, so that's about here. And what happens is the same thing happens. I'll get you to plot this yourself. You can stop and plot it at any stage, but you end up with a graph that sort of comes around like this. Never touches the line and goes that way. Now that's a typical graph of a hyperbola. Now you can graph, there's a lot more in a lot more accuracy than I have. And notice that I made a mistake with the signs. You've got to be very careful with the signs and get the negatives with the negatives and so on. But you've just got to practice having a go at plotting these, and then you should be right with them. But that's a typical hyperbola. And I'll just go back to the previous screen. That's a nice, neat one. And I think if you actually went and drew one, this is probably what you see. Now I'm just going to pause the tape, and I'm going to open up a program, one that you've been using, GeoGebra, and we're going to actually plot y is equal to 6 over x, so you can actually see what it looks like. GeoGebra, and we're going to type in at the input value the equation y is equal to, now it was 6 over x, so 6 at the top, that's your constant, so there's your reciprocal relationship, and when we press enter, it should work. There it is there. Now, what we might do is just to scale it in a little bit, if we can. But I think you can see, now I'm not sure how to scale it in this particular version of it, but if you have a look at it, I think you'll find that you can see how the graph comes down along here and down along here, and you can actually see the numbers. Now you'd really have to reduce the scale a little bit to see the whole thing, and yeah, but that's basically how the graph will look. And you've got to get used to mainly calculating the values of y for any value of x. So you're going to have a little bit of a practice of this in your practice time in class.